esteemed research person, Dr. Debesh Bhowmik, my dear colleagues, dear faculty members, and beloved participants. It is a good privilege for me to officially inaugurate the international seminar on the topic application of economics on economic theory, organized by the Department of Economics, my school. Dear friends, economics is the most popular and dynamic subject in the contemporary world. It is a subject that encompasses everything around us and affects life in various ways. Economics is a part of our life and we cannot live without it. But wrong application of economics in our life will bring us down. Therefore, proper application of economics has been inevitable. It must congratulate everyone to the webinar and thank the Department of Economics of my college to have organized the webinar. Thanking everyone.
Good morning, everybody. Thank you, Principal and Professor Nishan of Nursing College, Odisha. And I am greatly privileged that you are eager to say something in a seminar. And since I am interested in applications of econometrics in economics, thereby I told Professor Aruna that I have to take a class how to apply econometrics in economics. So in that target, I wish to take a small class before your student that how to apply econometrics. Therefore, just I am presenting a class lecture. You can enjoy and you can ask any questions, and I am encouraging to students of this college to ask something if there is any problems. Now I am starting my event. Is it visible? Is it visible, everybody? Okay. Now, today's topic is Human Development Index in India. We have collected data of Human Development Index, GDP per capita, growth of GDP, unemployment rate of India from UNDP and World Bank from 1990 to 2016. We will try to fit data in economic relationships of Human Development Index with those variables. So, to verify this relationship, we will apply econometric tools with a software, especially today eViews. You can also apply eViews, SPSS, Great L, and so many statistical software to find the results of econometric tools. Now, if we understand basic concepts of econometrics, we have fundamental ideas that econometrics is nothing but use of statistics plus mathematics plus economics. When both the three subjects are combined together, we will find a subject that is econometrics. Especially, don't fear about econometrics. I am studying from your basic concepts. In your school days, you have plotted a single equation, y is equal to 2x plus 10. Say y is equal to 2x plus 10. You have done it in your school days, and you have plotted it by assuming values of x, values of y, and then you have plotted whether it is linear or non-linear, whether it is upward or downward, etc. Then you have also solved like this: 2y plus 3x equal to 5, and y is equal to 5x plus 3, and you have solved, and you have get values of y and x, and you have also plotted it in graphs and also solved. And in statistics, what you have found? We have found the regression equation of y is equal to 2x plus 6. And also in econometrics, you are trying to estimate the constant, that is 2, or if you assume it a, and the slope if you assume it b, that is 2, and constant c, and estimating constant and the slope using various tools. And hello. Yes, I will use. I am just saying the backgrounds. Then what your task is regression of y on x. Then what you estimated b. Then say b is equal to b dash or b hat, etc. This is the formula. What is the formula? N equal to sum of n into sum of xy minus sum of x into sum of y divided by n into sum of x square minus sum of x whole square, which is equal to covariance xy by sigma square x, or r, that is correlation coefficient, into sigma y by sigma x. Here sigma is equal to standard deviation. In this way you find the estimate of a, that is y bar minus estimate of b into x. So this is your statistical tool, but now we will go more advanced in that way, that is by applying the statistical tools. We have data. What is the data? Data from 1990 to 2016. Y is equal to Human Development Index. This is the data. X is equal to GDP. X2 is equal to GDP per capita. X3 is equal to GDP growth rate, and X4 is equal to unemployment rate of India. We will find the nature of Human Development Index, and we will find the relationship between Human Development Index and GDP per capita, GDP growth rate, and unemployment, etc. Now we can go directly to eViews. It is, have you seen this? Hello? Hello? Hello?
Yes, sir.
Yes, sir. It's visible, sir.
Visible? Okay. Now,
Yes, sir.
this is the eViews. Just follow. This is the eViews software, and we have done the entry of all the data of Y, that is Human Development Index, from 1990 to 2016, and also X1, that is GDP, X2 GDP per capita, X3 GDP growth rate, and X4 is the unemployment rate. Now, first we will simply the nature of Human Development Index. Nature, I means the this is the we will find the trend line. That is the nature. How will you go? We will go first week, then go to estimate equation. Then we will write log of y, that is HDI, space, then C is equal to constant. Then we will write the T means year, all the years, and then we will click OK. These will be our results. What is the result? Result is dependent variable log of y. C is equal to constant, T is equal to career. Hello. PPT. Oh, okay. Okay, so I am going to my PPT. No problem. Is it visible? Visible. Oh. It is visible.
Sir, actually, sir, what happening here? Sir, it is visible, but it's not properly visible. So letter is not visible. That's why we are getting a little problem, sir. No, it's not.
Achha.
Same situation.
Okay.
Same situation. No. PPT is showing, but letter is not properly visible. That is the problem. No.
So, visible?
Yes, sir. Now it is visible, sir.
Okay.
Okay, sir.
So, this is our data. Okay, this is our data. X1 is the GDP, X2 is the GDP per capita, X3 is the growth of GDP, X4 is the unemployment rate, Y is the Human Development Index. So I have said that in statistics you have find the regression equation, and you have find the regression equation like this. And in econometrics we will go further and we will test some estimation, and we will estimate the regression equation of slope of the B and also constant C. Now in the software we have tried in this way. In the software we take log of y, and C is the constant and T is the trend line. So this is the coefficient of trend line and this is the coefficient of constant. So in this coefficient we find that and this T statistics is the significant level, and which shows by probability. This is 6%. 0.6 means 6%. So this log y means HDI. HDI is increasing at the rate of 6.19% per year. This is the equation. Log of y is equal to minus 1.265 plus 0.06196 into t. And this is in the bracket, minus 2.45 is the in the t value, 1.92 is the t value. This is significant at 6% level. What does this equation means? Equation means Human Development Index of India has been increasing at the rate of, it will be wrongly written, at the rate of 6.19% per year from 1990 to 2016, which is significant. It will be 6% level, and R square is equal to 0.192. F is equal to 3.71. This is significant. Now, this can be plotted in this way, and this plotted from the software. We will go to the graph and we'll find. And if we click OK, then we'll find this graph. Log of y means HDI measured in this axis, and this is from 90 to 2016, and this is the fitted line. The green line is the fitted line, and this is the actual. Red line is the actual. So this is slowly increasing upward. Now, next, this HDI, Human Development Index, in 1996 it is upward. In 2004 it is also. We will quickly estimate and write log of y space with space c and space log of y, and we'll click OK. We will find the result. This is the result. We will find this type of result where dependent variable is log of y and independent variable is log of y, that is Human Development Index. Dependent variable log of x means GDP. So where constant we find 6.659 and coefficient 0.1953. This coefficient is significant whose t statistics is 1.94. This is significant at 6% level because its probability is 0.06. And constant c, whose coefficient is 6.659, whose t statistics is 47.33, which is significant at 100% level. And the values of R square is equal to 0.1313, F is equal to 3.77, and DW is equal to 0.308. This is written in this way. In a regression equation, we can write in this way: log of x1 equal to 6.659 plus 0.0153 log of y. This log of y is nothing but HDI, and x1 is equal to GDP. Then 1.94 is equal to t statistics, which is significant. Star means significant, and t values of constant equal to 47.31. Star means significant. We have find the R square, F, and DW, and from this equation, what we can say? We can say that if 1% rise in Human Development Index in India per year during 1990 to 2016, then India's GDP will increase by 0.1953% per year significantly. So the relationship is positive, and Human Development Index induced to increase GDP year by year at the rate of 0.1953. Now, next case. Next case is the relation between Human Development Index Y and GDP per capita. X2 is GDP per capita. Similarly, we'll go to the views, open the data, and we will go to quick, then we will go to estimate, then we will write log of x2 space c space log of y. We will click OK, and we will find the result. And this is the result. We will find this type of result where constant whose coefficient 6.55, whose t statistics is 56.16, whose probability is 100%, and log of y whose coefficient is 0.1631, whose t statistics is 1.59, which is significant as 6% level. This is the R square. F statistics, this is the F statistics, and this is the DW. So we can write in this way that log of x2 is equal to 6.555 plus 0.1631 log of y. These are the t values. These are the R square, F, DW, etc. So this is the regression equation. But in econometrics, we will say this is the estimated value of x2 and y, and whose estimated equation is like this. This is the difference between statistics and econometrics. And this is the econometric equation we have found from the views. So this means that HDI and GDP per capita have positive relation, where 1% increase in Human Development Index per year from 1990 to 2016 will rise 0.1631% in GDP per capita per year. This is significant as 6% level. In the next case, we will also find the relation between Human Development Index Y and the GDP growth rate x3. In a similar way, we will go to the views software. We will open the data. We will go to quick. Then we will go to estimate. We will write the log of x3. Giving space, we will write c. Giving space, we will write log of y. And we will click OK. We will find the following results. These results is dependent variable log of x3, independent variable is log of y. Observation 27, that is sample means the year from 1990 to 2016. The variable c means constant, whose coefficient we have found 1.849. Whose t statistics is 20.26, whose probability is 100%, which means it is significant at 100% level. And the coefficient of log of y is equal to 0.0309, whose t statistics is 0.47, whose probability is 63, that is, it is not significant at 5% level. It is not significant at within 10% level, but we have got the positive relationship, and the relationship we will write in this way that there is a positive relation between HDI and GDP growth rate, and where 1% increase in HDI of India lead to 0.0309% rise in growth rate, which is not significant at 5% level because we did not give here star. R square is equal to very, very low, F is very low, DW is okay. So we did not find a significant relationship, but we find a relationship, positive relationship, which means if a country increases GDP growth rate through HDI, so we have to increase HDI so that we have to get a rise in GDP growth rate. Now, if we go to X4, that is unemployment rate, and Y, that is Human Development Index, then we'll similarly as before, we'll go to eViews, we'll open the data, we will go to Quick and go to estimate, and we will write log of X4 space C constant space log of Y, and we will click OK. We will find the such type of result where log of X4 is equal to unemployment rate of India and Y is equal to Human Development Index. What is the result? In the result we get the coefficient, that is constant. The constant for constant we got the coefficient 1.368, and for log of Y the coefficient is minus 0.0179, whose t statistics is minus 1.519, which is 14% significant, that is below the 5% or 10% level. But the constant t values is 82.86, it is significant, and whose R square is low, 0.08, F is also low, 2.308, and DW is also low, 0.95. We have find that education expenditure of SAARC countries has shown a negative impact on HDI, and also we find a negative relationship between health expenditure and the HDI, and also there is positive relation between GDP per capita and HDI of SAARC countries. So in SAARC countries, if there is 1% increase in GDP per capita, then HDI would increase by 0.1782% per year. If 1% increase in health expenditure of SAARC countries, then we find that there was a decrease of 0.0367% HDI per year, and if there is 1% increase in education expenditure per year, so HDI decreased by 0.0341% per year decrease in HDI in SAARC countries. These are the results we have found during the period from 1990 to 2016. But what these results can say or can predict that the education expenditure and HDI was not significant. This should be positive, because if there is increase in education expenditure, there should be increase in education index, which can intend to increase the GDI, increase the HDI in SAARC countries. But this was not shown here, so this was insignificant. But in case of health expenditure in SAARC countries, we find that in spite of increase in health expenditure, HDI did not rise, but it was significant. Which does it mean? It means that the health expenditure, increase in health expenditure in SAARC countries is so low that which could not a positive impact on the HDI. But increase in GDP per capita, which shows the increase in HDI. So in that case, what should be our planning framework? in planning framework, we should increase in the health expenditure in that fashion so that life expectancy in health, or if we increase in education expenditure in that way, so that the years of schooling can increase, so that the human capital will be best utilized in the process of growth, in the growth process, so that the HDI can intend to increase. But in SAARC countries, it was not found. So there was a fault up in policy framework and in actual cases. So what we have found in our class today we find that in India, human development has positive impact on education, that is on GDP and GDP per capita, and also growth rate and unemployment rate. But in unemployment rate, increase in HDI reduced the HDI, but it was not significant. But in other cases, all results we find the significant at 6% level. So in India during 1990 to 2016, somehow the indicator of GDP per capita and growth rate of GDP and unemployment rate have some fruitful effect on the HDI level or vice versa. So how will utilize the data and software, statistical software to economic analysis? We will collect the data. We will entry the data in the particular software. We will go to the software. We will give command of the variables to be estimated, and then we'll click the OK, and we'll get the result, and we will write the equation, and then from that equation we will interpret the result. So thank you. Now I am asking some questions who are watching these classes, and I welcome everybody.